Hello, let's solve This Sudoku Has One Solution by Clover. So this is a special showcase video, which I haven't done in a long time, but I usually do live solves, but I solved this on my own through recommendation, and it was just wonderful. I loved this puzzle, so I had to showcase it, even though I've already solved it. That doesn't mean I won't get stuck. I haven't written out a solve path. Hopefully I don't get stuck. I have solved it once before. It was a couple days ago. I do know generally how it goes. So yeah, I won't ruin more of it, but it does showcase an interesting piece of logic or concept in Sudoku, which I'll go over during the solve. So let's go over the rules in case you need that. So in every row, every column, this is a column, every column, and 3x3 box, we are placing the digits 1 to 9 exactly once each. The grid has fog in it. That all these cells that are gray are fog. Now we have to reveal the fog, and the way we do that is by placing a correct digit in any cell. So if I were to place a correct digit in this cell, then all of this fog would reveal. Now, fog puzzles are one of those that are honor-based, because you could, of course, just plunk digits until one of them's correct and reveal around it. But the intent is not to guess. The intent is to logically solve the puzzle with the information you have, but use all of the information you have. So additionally, this grid has killer cages in it. It does not have any clues in it other than killer cages, including given digits. So the fog will never reveal anything that's a given digit. It'll never reveal like Renban or only killer cages. And so how do killer cages work? Well, you're going to have some number of cells that get surrounded by dotted lines. Let's say that these cells were surrounded by dotted lines. They'd be completely surrounded by dotted lines. And in the top left corner, so in the top row of the killer cage, the leftmost cell of the top row, there will be a clue in the top left. So if this cage went like this, the clue would be there. If we had a cage that did something like this, the clue would be here, right? And then the cage would be drawn around it like this, right? So if I bring out my tool here, it would be dotted line, but the cage would look like this, right? You'd have a dotted line there. You'd have a dotted line there in this cage. And then the clue would be here, right? In the top left corner. So let's use a corner mark. So the clue would be up there where that 1 is. That clue tells you the sum of the whole cage. So you take all the digits that go in the cage and you sum them, they sum to that clue. And additionally, digits can't repeat in a cage. So if I were to put like a 2 somewhere in this cage, I couldn't repeat the 2 anywhere else. So that, I'm going to just hit restart here. Actually, I'll restart before I start. Those are all the rules. Make sure you use all the information given to you, and pay attention to the title, which is This Sudoku Has One Solution. And I'm going to get started right now. Okay, so this 3 cage here, we know that it extends to the right. We know it's going to do something like this, because if it didn't, first of all, it can only be 2 in size. It could be 1 or 2 in size, but we know it's not 1 in size because there's no border here, so it has to extend here. But then now it has to stop because it has to be a 1, 2, adding to 3. Now this cage here, we know that it goes to the right, and we know it goes down because these aren't here. We also see this little lip here, so we know it does this. But a 6 cage can only be 3 in size because 1 plus 2 plus 3 is 6. So that's going to stop that cage. And I'll erase these black outlines. In fact, maybe we shouldn't use black. Let's use blue, just so we don't get it confused with like box borders or anything like that. Oh, blue doesn't look so good on the fog, does it? All right, half this puzzle will be deciding what color to use. I'm going to go with green, and we'll stick with it. And then once we actually reveal the cage in its entirety, we'll get rid of that. But this is how this cage is going to go, and it's going to be 1, 2, 3. Now, we do have a 1, 2, 3 triple here, and within this 1, 2, 3 triple, the 3 is limited to down here. That means this can't be a 3, because if this was a 3, and I'm going to avoid putting large digits in case we accidentally reveal. We don't want to accidentally reveal. If this was a 3, then we'd have too many 1, 2s, right? We wouldn't be able to place a 3 in that triple. So that means this is not a 3. It's only from 1, 2. Now at this point, you may be wondering, how the heck are we supposed to make progress? There's nothing. Well, there is something, and it's called a unique rectangle. This is a deduction that depends on what's called uniqueness. We basically add another assumption to the rules of Sudoku, which is the puzzle I'm solving has 1 solution. If it has 1 solution, then we know that this must be a 3. Now, why? Well, if it wasn't a 3, we'd have this pattern here. Now, the key part of this is that we have these bi-value cells that all have matching digits in it. Basically, we've got a bunch of 1-2 pairs. So you think about these 1-2 pairs. This 1-2 pair, what's it affect? It affects its row, and it affects its box. This 1-2 pair. So actually, let's highlight every cell that can't be 1-2. Let's make those red. These cells can't be 1-2 because of this 1-2 pair. This 1-2 pair, these cells can't be 1-2, right? This ends up with 3 in this case, right? So none of those can be 1-2. But we also have this 1-2 pair, so none of these can be 1 or 2. And we have this 1-2 pair, so none of these can be 1 or 2. So now here's my question: how does this 1-2 ever get resolved? Is it 1s here with 2s here, or is it 2s here with 1s here? What's going to resolve that? Well, we're certainly not placing a non-1-2 in these cells. They're 1-2 pairs. We're not putting a 1-2 in any of the cells that see any of these cells because they're all red. None of them can be 1-2. So there's literally no way to do it. Nothing in this Sudoku can resolve these, and so there would be at least 2 solutions. And since we are assuming there is only one solution to the puzzle, that means that, if I undo all the way, this cannot be a 1 or a 2. It must be a 3. So we can place the 3, and that is correct. All right, so now that this cage got revealed, we don't need the outline around it. Now this 7 cage, 7 you can only do in 3, up to 3, and we see there's no border here. So the 7 has to do at least this, right? But including this cell here is all it can include, because 1 plus 2 plus 4 is 7, and we can't do 4 cells add to a minimum of 10, right? Because we can't repeat in cages. Now this cage here we know is going to extend here. Oops, we know this cage here is going to extend here. But we don't know if it continue, like where it's going to continue. We just know, actually we don't even know if it has a border up there, but we know it takes this cell. So maybe I'll just draw it that way. We know this cage takes that cell. But here, we do have this 1, 2, 4 triple here. So it's very similar to what we did before, where this can't be a 4, because if it was, there'd be nowhere to put 1, 2, 4 in this row. But now let's think about it. Can this be a 4, right? If this was a 4, then this would be a 1, 2. Basically, can this be not a 4? And so now we have this pattern. It's going to be very similar, except now we have to use all three sets of these pairs. So there is no, if we can cover them with 3 rows, we can cover them completely with 3 columns, and we can cover them completely with 3 boxes, 3, 3, and 3. Because those all match, basically what we know is all these 1, 2 pairs that have happened have eliminated any ability to resolve them. And so there must be 2 solutions. So that can't happen. So this has to be a 4, and this is not a 4. Okay, and so now we know that this outline here is telling us that it continues down here. Now we don't know if it continues further, so we don't know what shape this takes, but we know this killer cage does that. Okay, and then this is revealed fully, so we don't need this outline here. I'm just going to do this. Actually, we know this outline, so let's just keep that. Okay, so we revealed an 8 cage. So let's think about this 8 cage. Well, an 8 cage always has a 1 in it, right? Because if it didn't have a 1 in it, 2 plus 3 plus 4 is the minimum we could put in, and that adds to 9. That's more than 8. So it does have a 1 in it. Now with the 1, we have 2 digits that add to 7 without using another 1. So that's only going to be 2, 5, or 3, 4. Now you should be very suspicious of the 1, 2, 5 option. So let's take a look at that. Well, we have a 1, 2 pair here. So that makes this a 5. And then that would make this a 1, 2 pair. Now we have all these 1, 2 pairs. And those 1, 2 pairs can be covered by 4 columns, 4 rows, and 4 boxes. So there does not exist a row, column, or box that could resolve this. So there would be at least 2 solutions. Again. So that's not possible. It cannot be 1, 2, 5. So it has to be the other one. It has to be 1, 3, 4. That's not 4. That's not 3. This 1, 2 pair tells us that this is the 4, and we get more revealed. Okay. So I'm going to note that this here extends down. Now we don't know, we don't know, and this does extend down as well. So we know cages don't overlap. I guess that's kind of not mentioned in the rules, but, oh, it does say non-overlapping cages. Oh, sorry, Clover. It does say it in the rules. I just didn't read it. So because we know the cages don't overlap, if this cage were to extend, it would have to go right. And if this cage were to extend, it would have to go left. But let's think about this. What is the minimum that these 2 cells could be? Well, they see 1, 2, 3, and 4. The minimum they could be is 5, 6. 5 plus 6 is already 11. So actually we know that this cage does this. and it is going to be 5, 6, and that leaves 7, 8, 9 up here. Now, how about this 11 cage? Well, first of all, it can't be 5, 6. That would cause a unique rectangle. I think we know enough about them by now that this is not allowed. They would make 2 solutions. So this is not going to be 5, 6. Now, we don't know how much it grows. Well, let's think about how much it could grow. Could it grow to size 4? Like, this is one example. Could it do this? And we know it can't escape the box to the right. So it would be contained within this box, and this box has a 2, 3 pair in it. So these would be 2, 4, 5, 6 at minimum. And that adds to way more than 11. The 5, 6 by itself is already 11, right? So that's not going to work. So we're definitely not 4 in size. Now, could we be 3 in size? And if we were 3 in size, we'd have to go this way because there's a border here. We do not escape this way. And so if we were 3 in size, the minimum we could put is 2, 4, 5. And the 4 would end up here, and this would be a 2, 5 pair, and that does add to 11. So that is possible. Okay, well, what if we were 2 in size instead? Then what could we do? Remember 2, 4, 5. Well, we can't use the 1 or 3, and we can't use the 4, and we can't do 5, 6. So the only option, if you think about it, is to do 2 and 9. So again, 2, 9, we can't do 3, 7 because there's a 3 in the box. We can't do 4, 6. I'm saying this wrong. 11. We can't do 2, 9. We can't do 3, 8 because there's a 3 in the box. We can't do 4, 7 because there's a 4 in the column. And we can't do 5, 6 because of uniqueness, because of the unique rectangle. So it could only be 2, 9. So in both of these cases, we were either 2, 5, 4 or 2, 9. There is a 2. So because there is a 2, now I'm not going to keep this 4 because it'll confuse us, but if this ends up 2, 5, that means that's a 4. Since there's a 2, that looks up, and that actually resolves this original deadly pattern we had. So that makes this a 1, that makes this a 2, a 1, a 2, a 1, and a 2. And we did reveal this cage. And we revealed this cage, so we don't need that. These aren't quite revealed, so we'll keep that. That also gives us this 1, gives us this 3 and this 1. Still, annoyingly don't know how this cage extends, but we did reveal some new information. So first of all, 23 cage, if you're at all familiar with Killer Sudoku, that should immediately trigger you because 23 and 3 can only be 6, 8, 9. It's literally the only way 3 unique digits up from 1 to 9 can add to 23. And then we also revealed this 15 cage, but let's fill this triple as well just for fun. 1, 2, we need 3, 5, and 7. Okay. So 15. Well, immediately, you know that's going to be from 6, 7, 8, 9 because it's either going to be 6, 9 or 7, 8. That makes a 6, 7, 8, 9 quadruple here, so this isn't 7. And additionally, the 7 in that quadruple is only over here. So that means this can't be 7, which means that this can't be 8. So we do need to add to 15. Okay. We also need a 4 in the box. This 4 looks in, and these are not 4s, right? That 4 looks in as well. And we can't put a 4 in this. Sorry, we can't put a 4 in the 15 cage. So the 4 ends up here. And we revealed an 11 cage. Now, we don't quite know what goes down here, but we do know that it involves a 5. So this 11 cage. What are our options? Well, we can't be 2, 9 because there's a 2 in the box. We could be 3, 8. We could be 4, 7. But if we did 4, 7, it would be this way. Now, the first question I would ask is, can we be 5, 6? It's kind of a let's think about the consequence of 5, 6. So if this was 5, 6, remember there's a 5 down here. So we can't make this also 5, 6. So we'd make a unique rectangle. That forces the 6 into this 15 cage. And that would force this to be 7. And this would be 8, 9. So this would be 6, 9. This would be the 7, and this would be 8, 9, right? Because the 6 would be forced into here. So that would be what would happen if this was 5, 6. Let's think about what would happen if it was 3, 8. Well, that removes 8 from here. That makes this an 8, and this would be 7, 8. So actually 3, 8, this can't be the 8, right? So we can only do 3, 8 this way. And then this would end up 5, 6. I think that's okay. And then 4, 7. This wouldn't be 4, this wouldn't be 7. That forces this to be 7. That makes this a 6, 9. And this would be 5, 8. So the only way that this is 7, 8 is if this is 3, 8. Like this, 3, 8. makes that 8, makes that 7. Oh, and that's an issue, right? So I didn't see that the first time I went through it because I was doing it in my head, but this can't be 3, 8, right? Because if this is 3, 8, that forces this to be the 8 in the 7, 8, 9 triple, right? I'll write it out without big digits. That forces this to be a 7 because there's only one place for 7 in the row now. And now what is this? How do we add to 15? We can't use the 8 again. So we can't do 3, 8. And so actually both cases, if this is 4, 7 this way, in that case, this ends up as 7, right? And this is 6, 9. And then in the 5, 6 case, right? In the 5, 6 case, this can't be 5, 6, and 6 is forced into here, and this ends up as 7. So we can put 5, 6 pair here, or 4, 7 like this. And in addition to that, we could in either of those cases, this ends up as 7. So we can place this 7 here. These aren't 7s. This isn't 7. This is a 6, 9 pair. That means this ends up not a 6, which I didn't mention earlier. And then this is 5, 8. Nice. So this is not a 5. Now we have, you might recognize this pattern. I've had it a few times. So we know that this can't be the 8, right? Because of our 6, 8, 9 triple. And then this can't be the 8. Otherwise, we'd end up with a 6, 9 unique rectangle. So the 8 gets placed here. Okay. So then we take a step. Oh, no, sorry. The 8. Whoops. I did the opposite of what happens. The 8 gets placed here. I was like, something's wrong. Okay. Sorry about that. All right. We have revealed a 17 gauge. So it's nice how fog kind of leads you through the solve path in a way. Let's think about this a little bit longer just to make sure I didn't miss anything. We know 4 is over here somewhere. Might as well mark that. We know 6 is in one of these two. Okay, so let's think about the 17 gauge. So, there is one thing that I did. Yeah, this is going to help. So we have this 1, 2 looking in here. We have this 1, 2 looking in here. We have this 1 and the 2 down here pointing up into here. So there's only 2 places in this box for 1, 2. So this is a hidden 1, 2 pair. And that helps a lot because now this cell is 1 or 2. So we can think about that. If this was 1, then these would have to add to 16. There's only one way for 2 cells to add to 16, and that would be 6, 9. But that's not allowed because if this was 6, 9, sorry, did I say 6, 9? I meant 7, 9, and that is allowed. Whoops. So this would be 7, 9. Sometimes I wonder about my mental math and if it will ever improve. But anyway, 16 plus 1 would be 17. So that's how this could be a 1. Otherwise, it's a 2. And if this is a 2, these need to add to 15. And this was my point. If it adds to 15, it can't be 6, 9 because we form this sort of pattern, this uniqueness issue, this deadly pattern. We've seen it before, right? It can be covered by 3 rows, 3 columns, and 3 boxes. Therefore, it is not possible to happen if we have a unique solution. So if this was a 2, this would be 7, 8. And it would go this way. So the conclusion is this is either 2, 7, 8 or 1, 7, 9. And so in that case, it always has a 7 in it, which is very convenient because that makes this a 6. And 6 plus 5 is 11. 8 and 5. Okay. I'm going to fill what this triple is left. We need a 3, 4, and 7. Okay. Now, can we learn any more about this? At the moment, I'm not sure. I'm going to fill this quad just for funsies. 1, 2, 3, we need 4. We have 5. We need 6. We have 7. We need 8, 9. Okay. Great. Not super helpful, but we did reveal this 5, which is from 1, 2, 3, 4. That's not 4, which means that's not 1. Okay. What else can we do here? There's a 7, 8, 9 triple here, which means these are all from 1, 2, 3, 4. Did I get anything else out of this? These are from 1, 2, 3, 5. It's for the row. I don't think we need all of this penciled right now. There's something I'm missing. I think I know what it is. Yes. It is where does 7 go in this column? Because it doesn't go in this 11 cage. It doesn't go in any of these cells. And then these pointer mark 7s here that have to go in the 17 cage, take 7 out of these two. So 7 is placed. So that's a 7. That's a 9. 7 plus 9 is 16. That has to be 1 and 2. Everything's correct so far. That resolves our 6 9s, which is great. It also resolves the 8, 9 here. These are not 1s. So this is a 2, 3, 4 triple. Oh, down here, perfect. These can't be 9 anymore. And so now we know that the cage extends like this, right? It's 2 plus 5, which is 7. We need another 4, as we said. So the 4 goes there. And sure enough, that is what the cage looked like. Great. So we have a 2-5 pair here, so we can actually fill a few more things. So, oh, the 4 in this column goes here. That gives us the 4 here, and now we've revealed more. Okay, but let's fill these pairs and triples. So we need 6 and 8 here. And then we need 1, 2, we need 3. Actually, this should be known. This is the 3. Nope. I'm wrong. It's a 7. Try again. And then in here, we need the 3 and the 5. Okay. Cool. 14 cage. This 6, 8 is very convenient, isn't it? Because this can't be 6 plus 8. So there's only one other. There's only one. We can't be 7 plus 7, right? Because that would repeat the 7. So there's only one other way to add to 14, which is 5 plus 9. And that we know the order. And that reveals more. There's another 5 cage here, and we know that it does this, right? Because 5 can't be 3 cells long, and there's no border here. Which means this can't be a 5. Oh, over here we get some digits. Let's do that. This is 3 and 5. That's 7 and 3. Okay. 14 cage. So here's a question. Does it do this, or does it do this, or does it do this? So the first question to ask is, we know that it includes these two. So what are the cell? What do we need in this row is what I'm trying to say. I'm going crazy here. 6, 7, 8, right? So the minimum that we could put in here is 6 plus 7, which is 13. So I think it has to be, so it could be 6, 7, 1, like this, or we could do 6, 8, which is already 14. In which case, so no matter what, we use the 6, right? That's the conclusion. And this may or may not be a 1. But that gets us the 8 and the 6 here, and these aren't 8. So that's kind of weird how that worked out. Oh, the key point here is it needed a 7 in it. Sorry, I did that a weird way, but I think the easier way to see this is the 7 goes in the 14 cage, which means that we need to, if we included the 8, it would add to 15. So there's no 8 in it. So that's the 8, that's the 6. And then now we know it has to extend down, so that it actually adds to 14, and that places a 1 here. Perfect. That cage was revealed, and we don't need the corner marks. That's not a 1, which means that's not a 4. 18, huh? All right, what else can we do here? We know that one of these is a 4, which means we know one of these is a 1. Oh, maybe this cell will help. 1, 2, 3, 4, 5, 6, 7. This is an 8. Okay, maybe that didn't help. We don't know how far this 18 extends, but we know this is only 8 so far, so it definitely does at least that. It can, so from here, it can't escape to the left because that would be an overlapping cage, so it has to escape down. Would it be helpful? I'm wondering if it would be helpful to think about, to just pencil these. Maybe it will be. So let's think about this. So 1, 2, 3, we need 4, 5, we have 6, we need 7, 8. All right. And then down here, we need 1, 2, we need 3, 6, 7, 9. There's something I'm missing. I don't remember what it is, so I'll have to figure it out again. It's fine. Maybe these triples will help. Probably not. It'll help eventually. We need 3, 8, 9 here. That's not a 3. And then over here, we need 1, 2, and 7. Okay, is there another uniqueness argument, perhaps? Well, let's think about this cage for a second. So at minimum, at maximum, this adds to 8. We could do another 8, that would be 16. So we definitely need to extend further, but I don't know if it goes left or down. I think I remember there being something a little bit more straightforward to do here. We know that these cages won't be 2, 3, but we know that already because one of these will be 1, 4. Okay, we know the other one won't be 1, 4, but that doesn't really help either, does it? 1, 2, 3. What am I missing here? It's not this box. Oh. I hope I didn't make a mistake somewhere, but I don't think I did. Is it that the 18 cage doesn't work with a 2-3? Okay, yeah. Oh, okay, yes. This has to be a 5 because one of these will be 2-3, and whichever one is 2-3 prevents this from being 2-3. Like, let's say this was the 2-3, right? It works the same for the other one. Let's say this was a 2-3 adding to 5. This couldn't be 2-3 because then we'd have a unique rectangle. Nice. One more use of uniqueness there. So this has to be a 5. Perfect. Because that resolves this triple. We can clean this up quite a bit. And now we know this cage, how it goes. So it actually ended up going left. In this cage, we know how it goes, of course. So with the 5, okay, so maybe we think about the 18 now. Okay, this is a 1-2 pair, first of all. So this is a 3-4 pair, and that actually places the 2, which should help. Okay, so this adds to 7, which means these two need to add to 11. Well, we're certainly not doing 7-8, so we use the 4, which means we're 4-7. Okay, so that adds to 11. That puts the 8 there. We reveal an 8 cage. It does not have a 9 in it, so that places the 9. So this is either 3, 5, or 6, 2. Do I know which way it goes? I assume there's some way to find out. We want a 7, which goes down here. All right. What do we know about these columns? 2, 6, or 3, 5. I think we might just have to pencil more. I'm not sure, though. Okay, we've got these 8s looking down. That puts an 8 over here. Got these 9s looking down. That puts a 9 here. I'm looking for more uniqueness. Okay, these 5s line up. So we need a 5. Yes, that's it. So we need a 5 in this row, and it can only go here because these two 5s see these cells. Nice. Okay, so that's the 5, which puts the 3 here. That's 6. We get the 4 and the 1, the 3 and the 2, the 7 and the 4, the 6 and the 7. Very nice. You know, this puzzle is almost a masterclass in like how to avoid creating deadly patterns when you're trying to set a puzzle, which is neat, or at least telling you, hey, you're going to need to place some kind of clue over these, over this deadly pattern, like a given or another kind of clue. All right, so what do we need here? 1. Actually, I should do this because there's an 11 cage. 1, 2, we need 3. We have 4, 5. We need 6 and 8. So we know the 3 is in this 11 cage. So it needs to go with something that adds to... Sorry for the cut here, but I made a mistake right after this, and it invalidated the end of this solve. So I figured I'd just do this part again since this is a showcase anyway. So we have a 6, 8, 9 triple here. That means that we need these to be 2, 7. This sees a 2. So that's the 7. This is the 2. We get the 1 and the 7. Here we need a pair. Includes a 1. So that's a 1, and then this is a 4. And so now these 3 need to add to 11, and we know they include the 3. So if we also included the 8, these would already add to 11, and that's no good. So this is going to be 3, 6, and then we have to use a 2 in order, and then this is a 9 in order to get to 11. And so now this 3, 6 tells us this is 8. We get the 9, we get the 6, 8, 9, 5, 2, 6, 5, 3, 8, 3, 6. All right, and now I'll go back to how after I solved it the last time for the conclusion. All right, it took me 25 minutes, even having solved the puzzle before. But yeah, this was just such a fun puzzle. I love how it led you through, and how there was just uniqueness deduction after uniqueness deduction being used to get you through the puzzle. Super cool. And of course, in case you were wondering, if you take all of these clues together without the fog, there is one solution. So the title is correct. There is only one solution to this Sudoku. It just got covered by fog, you know? Awesome. I hope this was a cool demonstration of deadly patterns and uniqueness techniques, which I don't use very often in my channel. But yeah, this was neat. Hope you enjoyed it. And if you did, then why not leave a like, subscribe, and a kind comment below.